Welcome. Here we're given the graph of a function g, and we'd like to sketch its second derivative. Let's begin by considering the first derivative. The first derivative goes from having a positive slope to a negative slope. This tells me that the first derivative is going to be above the x-axis, then below the x-axis. As you can see, it's going to have a negative slope overall, and that tells me that the second derivative will be right here. Now we can illustrate this more clearly by actually sketching the first derivative. Of course, we begin wherever we have a peak, that's here, or a valley, of course, max or min. So right there, drop a little dotted line to the x-axis, and this is where your derivative function intersects the x-axis. And like we said, the slope of this parabola is positive here, so the derivative must lie above the x-axis. And the slope of this function is negative here, so the first derivative lies below the x-axis. Now, what is the slope of this blue line? It is negative, so our second derivative would be right here. This is y equals g double prime of x. And here we have y equals g prime of x. And of course, in black, y equals g of x. All right, let's continue. Okay, so here we have our second curve. Let's go ahead and find all the maxes and mins. So here's a max, here's a max, here's a min, here's a min. And we're going to go ahead and connect these max and mins to the x-axis using a dotted line, really lightly penciled in essence. And then everywhere this dotted line intersects the x-axis, we know our first derivative function will intersect the x-axis. Now the slope of this curve is positive here, so I know my derivative must be above the x-axis here. So I'm going to go ahead and just do that for now. To the right of this max, the slope is negative, so I know that the slope will be below, that is, the derivative will be below the x-axis. So now let's figure out what's going on in between. The slope is least steep here and here, so those are the closest points to the x-axis, and it's most steep here. So I'm going to do this right here. There we are, and now let's connect these dots as best I can. There we are, and go above the x-axis here. Now, from this maximum, the slope remains positive until this maximum, so I'm going to do the same thing here, whereas I sketch the curve above the x-axis, and then here we are negative. This slope, again, is not as negative as, say, this one. So the point would be closer to the x-axis here, whereas it would be further from the x-axis here. And there it is. There is the first derivative of this curve. So this is y equals h prime of x. And of course, here in black, I have y equals h of x. Let's go ahead and repeat this for the second derivative, h double prime. So my maxes that I'm looking at now are not the ones from my original curve, but the ones on my first derivative function. So that would be here, here, and here. That is where the first derivative function intersects the x-axis. And I'm going to lighten this just to make it really obvious which 3 points those are. The first derivative has a negative slope here, so I know the first derivative should be below the x-axis here. Now, the first derivative has a positive slope here. So again, this is pretty flat, this is pretty flat, so I'll have points very close to the x-axis. This one is very steep, so I'll have points further up, above, away from the x-axis. And connecting them, I'll get a curve that looks like that. Now the slope of the first derivative here is negative. And so it's a bit negative, gets more negative, then less negative, and less negative as it approaches 0. So let's try to mimic that. We're kind of negative here. We're getting more negative, and we're coming back and being less negative. And now for this last spot, the first derivative has a positive slope. It starts off a little bit positive and gets more and more positive as we go on. So we're just a little bit above the x-axis, and we're going further above the x-axis, becoming more positive as we go on. And this is y equals h double prime of x. I trust this video tickled your thought train.